producers of this show were crazy enough to give me one blackboard, a bunch of pieces of coloured chalk, and 5 or so minutes to describe America's energy challenge. So let's start by actually drawing a map of America. Remember that I grew up in Australia, so I'm going to get some of the details wrong. There we go, California, that's where I am today, up there to Washington. So here is North America. North America uses 3.5 terawatts of energy or power in total, and about 0.8 of those terawatts are the grid. So that's the electricity grid that we know. Let's put all of this in perspective for the planet. So over in this corner we've got planet Earth. Planet Earth uses 16 to 18 terawatts total. That's for all of humanity. All right, so let's say first off all we want to do is make the grid, decarbonize the grid in say 10 years. What do you need to do to decarbonize the grid? Well, let's remember there's a couple of different technologies for decarbonizing the grid. We can use nuclear, that's an option. We can use wind, which we learned about. We can use solar. Let's make solar coloured. And then we have biofuels. And we have geothermal. All right, so let's put all of these technologies on our map of America. So geothermal is sort of mostly concentrated roughly here where, you know, not unsurprisingly, we have earthquakes and the earth moves a little. That creates the heat. Wind is typically, there's a little bit on the coastline, sort of, you know, out here, quite a lot off this coastline off here. That's why it's important to do offshore wind power. But this is really where all the wind in North America is, in this middle section. Huge amount of power, so we need to put a ton of turbines in here. I'm not sure what a geothermal plant looks like, so let's call it a red thing with a couple of holes drilled to get the water down and back up again. Then we have a whole lot of solar energy down here in the southwest. Also some solar energy over here in Florida. We'll call that yellow. So we need to put a whole bunch of solar cells and mirrors that will do solar thermal. And we put those here and here. All right, so when we look at that, we see, wait, there wasn't a whole lot up here in the northeast. And then what actually happens is, you know, we've got cities up here and lots of people live up here, and this is where there's a lot of demand for power. There's a lot of demand for power up here. Also, in California, Southern California, tons and tons and tons of people. And then more and more, you know, in the middle here around the Great Lakes. So to decarbonize the grid, we got to get the power from these places where the power can be produced to the cities. Okay, so this is the importance when you hear people say we need a new grid infrastructure. That's so we can push this power around from here up to here, from here into here and into here, from here down into LA and up into San Francisco, from here down into Florida, and from a whole lot of these up into New England. It's probably also why you should consider nuclear. We have nuclear here. You probably want to put a bunch of the nuclear plants up here to power this part of the world. All right, there's another problem. It's not really a problem. It's completely solvable, but we actually have to consider it if we're going to design this whole system. The thing to emphasize is engineers do know enough to build this whole system. We can do it with technologies we have today. It is completely possible. We just have to be smart about how we do it. So, wind power, as you know, the wind doesn't blow all day, every day. Sometimes it doesn't blow. This is something we call capacity factor. So really you get wind around about 30% of the time. So if you install a 3 megawatt wind turbine, you get about a megawatt out of it, averaged over the year, and you get some high bits and some low bits. Solar, again, it's dark at night, there's good sun in the day, summer there's more sun, winter there's less. So this has a capacity factor of like 30%. Now, when you're sitting up in New York, you want to make sure your heater or your air conditioner is working all the time. So these 30% don't really work for you. So this is why we want to use things like nuclear, potentially, or geothermal, as something called base load power. Because geothermal and nuclear you can use all the time. Now, we didn't talk a lot about biofuels. We can put biofuels in a bunch of other places. The convenient thing about biofuels compared to these other technologies is that it can be turned into a liquid fuel that can be used for aviation or transportation. Problem with biofuels is it's going to take a lot of land area. On the plus side, again, however, you can put a lot of biofuels up here in concert with your wind turbines. So maybe we need a little corn plant or something to represent the biofuels. But, biofuels will be a small component of this picture as well. Okay, so we've got geothermal and nuclear for base load. We're going to have biofuels to get a small portion of liquid fuels. And we're going to have big wind and solar plants to provide actually probably the majority of the power here. The reason why is they look to be at the moment like the cheapest source of power. So it's important to remember that we're setting goals for ourselves like doing this, 0.8 terawatts of the electricity grid, and we want to do that in 10 years, right? So I know that we can build those wind turbines, we can build those solar cells, we can build those geothermal plants, we can build those nuclear power plants to do that. But one thing we really need government to step in and do, because it's the type of thing they can do, is help us build this grid. We need this grid to be able, it's basically a new grid, not a lot of overlap with the old grid, and we've got to pump all of this energy around from the places where it's produced to the places where we use it. It's not liquid fuel, it's not coal, so you can't drive it there, you can't put it on a railway line and get it there. You actually just have to move this electricity grid around to supply the people with the power they want. How much is it going to cost to do that in 10 years? 0.8 terawatts. In reality, we can install today wind and solar technologies at $2 per watt. So this is roughly a $2 to $5 trillion project. Given what we're spending on the bailout and stimulus, this is completely doable. You want to put people to work doing real jobs. This is real jobs. This is installing real machines. It's installing an awful lot of them. It's manufacturing a huge number of machines. It would actually achieve the goal that we want in terms of stimulus. It would achieve the goals that we want in terms of creating at least that grid portion of our power without carbon. And there's no reason why we shouldn't just start tomorrow. The technologies are here. The know-how is here. We just need to do this.